Kelas gila. Tidak.
Hello, good morning.
Good morning, doctor. Ohio.
Hello, can you hear me?
Hello, Dr. Ken.
Good. Okay, let's see. Have you guys downloaded the where is it? This one? Have you downloaded the exercise on a tutorial on chapter 2 on e-learning?
Alamak.
Anyone has tried this one yet? We would like to discuss.
Alamak.
Anyone? Have you tried this one? We look at this question. Question number 2. Please look at it.
Sketch and full certifier. Macam tu betul.
Okay, baiklah. Ada yang buat tak soalan tutorial? Belum buat ke?
Belum, doktor.
Belum. Tolong buat soalan 2 sekarang.
Soalan 2.
Instantly. Boleh nampak?
Six face.
If you have done that, put your answer on WhatsApp group so that we can see it and discuss.
Single face, halfway controller. Single face. Single face, halfway. Mami. Mami. Rectifier RL. Supply with 120 VRMS. 60 Hz. Firing angle 45 degree.
Okay. Question number 2, number 1. Can anyone send your picture here? I'm not seeing anything yet. If no picture, then how do we discuss? Come on. It doesn't matter it's correct or not right. We are discussing here. Anyone doesn't understand the question or anything you want to ask regarding the question? Nur Nazwa, ada tak? Nazwa tak ada eh? Kenapa attendance ada? Muhammad Afzal ada tak?
Ada.
Nasib baik ada. Mana pergi Nazwa ni?
Tak, I already send the picture. Question number 1.
Siapa?
Aisyah Akram.
Aisyah.
Hmm.
Wah, cantiknya. Tak muat. Yep. Oh, you pakai table lah. Can you guys see? Aisyah nak explain sikit tak?
Explain. Saya takut saya sedang tak confident.
Tak confident. Build your confidence now.
What I understand from this question is it talks about the single phase half wave control, meaning that the half wave. So using RL load. Okay.
Then.
Using,
Then?
hello? RL load.
Continue.
And then from here we know that RL load means that we have R and L, resistant and inductor. So for the number 1 question, it tells us to draw the circuit that describe the half wave control. So from here we know that the graph will appear. The graph.
The graph? What graph?
Yeah. What I understand about the half wave RL load, there is the resistance and that's all from me.
Guys, for tutorial, right, I'm not recording, yeah, because it's going to be lengthy, so you take your own notes.
Okay, Doktor.
Dengar tak? Aisyah, sini dia tulis apa? A single phase half wave control rectifier kan?
Yes. Oh my
Yes,
god.
control rectifier.
What does it mean by control rectifier?
Control rectifier means that dia control lah, regulated. Macam
Dia pakai apa? Switch apa?
dia pakai switch
Diode?
ni yes, diode.
Diode.
Yeah.
No.
Diode tu tak boleh control kan?
SER. Yes, SER.
Macam mana nak lukis diode? Ini diode kan?
Oh, ya. Faham. Okay, nampak dah mistake.
SER macam mana?
Ya, ada tanda tu. Yes. Macam.
Okay, so this one is SER. Make it SER. How to draw SER? Okay, please alter. Okay, amend your answer. Tambah satu line lagi. Apa dia? G kan? Gate. And then it's connected to R, correct? You have a resistor here. You have an inductor here. 0.1 and label already. We out carry correct. Apa ni? Kan? I hilang.
Oh, okay.
Your I is not there. You have the arrow, but I tak ada.
Oh, okay.
I can. I. KBS, okay. Sine wave is correct. All right. Everything done. Good. So number 1 is correct. Thank you, Aisha. Yang kedua.
Sorry, Prof. I want to ask that one. That one is S or G? You label.
Gate lah. Gate.
Gate. Okay. That one also can label.
Gate. Gate. So number 2 kan, sketch the load voltage and current waveforms. Supply as the reference. Label correctly. Anyone come on, send me the diagram. We're supposed to do like this, checking your answer because I'm not in the real site. Anyone is in UTM now? Ada orang kat UTM tak?
I think
Mostly, Doctor.
Tu tak ada bunyi pun.
Most of us.
Lelaki ada tak lelaki yang kat UTM? Tak ada, semua perempuan.
Ada, Prof.
Nasib baik ada. Siapa free? Kita nak pergi semak bilik lah, tengok bilik kursi dia okey ke tak. Kalau siapa free, kita pergi semak bilik ya. Nak tengok distancing dia okey ke tak. Kat mana bilik kita? P19A bilik tutorial 6 dan bilik tutorial 7. Kalau tak muat semua orang macam mana ya? Ada yang duduk kat koridor kot. Cepat, siapa nak hantar gambar ni? Soalan yang kedua ni. Tesla, are you here? Oh, Tesla is not here. Okay. Anyone send me anything? Not yet. Come on, cepat. Aisyah ada lagi tak? Semua tunggu Aisyah je kan? Siapa lagi kat sini? Mana Azal tadi? Afzal. How to spell? Afdal ke? Afzal. How to pronounce your name? Ada D kat sini ni.
Afzal.
Afzal. D tak ada bunyi lah.
Tak ada bunyi lah.
Gambar mana?
Dah puas sekejap. Sekejap.
Ariel ada? Ariel pun tak ada.
Ada, Doktor.
Ada? Mana gambar?
macam mana nak buat ni?
Sketching gambar. Semua kena tahu buat ya. Sebab apa? Kita punya test bila? Tahu tak best test bila?
30/4 pukul 9 malam.
Oh, saya tak bagi tahu lagi kan?
Itu dalam course information.
Oh, ada kan? Okey, baguslah. Ini dia. Test minggu ke-6, 30 April, 9 hingga 10 suku. 2 soalan. Itu permintaan dia lah sebab saya kena buat soalan kan. Bos dah suruh buat soalan, tak buat lagi. Okay, cepatlah. Masa dah habis ni. Mana gambar dia?
SER.
Okey, dah ada orang hantar gambar Mari kita tengok.
Kita tengok.
Siapa hantar ni? Ariel. Cerita sikit.
Tak tahu nak cerita apa, Doktor.
Tak tahu nak cerita apa ya. Tak apa. Kita tengok betul tak. Gambar yang pertama tu apa? Voltage ke? Okey, voltage. Yang kedua current. So, betul tak Aisyah? Dia bagi information apa?
Aisyah mana? Ada 3 Aisyah.
3-3 lah.
Dia ada firing angle dengan beta.
Ariel, kenapa dia punya voltage tu macam terapung kat udara ya? Dun. Memang dia terapung floating. Ni x-axis kan? Ni floating. Kenapa ya? Soalan ada bagi apa lagi tak? Soalan dia cakap apa lagi? Ada benda ni kan? Firing angle. Betul tak, Aisyah? Firing angle mana?
So just start in at 45 degree.
Dia tak ada benda ni. Okey. Lepas tu, kenapa dia terapung? Tak pasti. Dia tak jawab. Lepas tu, current dia continuous ke discontinuous?
Discontinuous.
Yang ni current dia continuous kan? Sebab dia terapung. Voltage dia pun terapung juga. Tak pasti kenapa. Kita nak jawapan lain ada tak? Kita nak compare. Aisyah dah siap? Ariel mana tak jawab saya? Kenapa terapung? Kenapa dia continuous? Kenapa tak ada alpha? Kenapa tak ada beta?
Yang current tu saya buat CCM Doktor.
Kenapa?
Sebab saya sketch yang atas pun dah salah lah.
Siapa ada? Mari kita tengok jawapan lain. So, kita dah tahu, senang nak buat salah ni. Nak test. Jadi, test tak boleh buat salah. Sekarang buat salah tak apa. Ada siapa lagi lukis tak? Kita tengok betul ke tak? Ada. Sengit lah. Macam nak tengok ni? Tak boleh rotate kan? Boleh rotate lah. Boleh kot. Rotate macam mana? Tak pandai lah. Boleh rotate ke? Tak ada option ni ke? Rotate. Cannot. Tak boleh lah. Macam nak rotate?
Control R.
Tak nampak. Oh, boleh. Okay. Nampak tak? Kita tengok. Ini VS, sine wave. Okay, input. Betul? Lepas tu ada pi dan 2 pi. Ini apa? Alpha equals to 45 degree. And then you have pi. And then you have beta, which is the stopping of the current. This is current. This is voltage. Okay. 225 tu apa? Siapa hantar ni?
Saya Sharifah.
Sharifah. 225 tu apa?
Firing angle.
Ini 180 kan? 45.
Plus 45.
225. Betul lah tu. So ini tak labelkan tiba-tiba 225. 180. Betul. Ada objection tak?
No. No objection.
Tak ada. So betul lah. V out dengan I out. Lukis ya. Betul Sarifah punya. Thank you. Dah label pun. Determine the conduction angle. Macam mana buat? Faham tak soalan dia tanya apa? Conduction angle tu apa?
Conduction angle is beta.
Tak. Beta to extinction angle.
Beta minus alpha.
So the situation here is the process or the operation will start when it hit alpha, right? Firing angle. And it will stop when? It will stop when the current touches 0, which is the extinction angle. Beta is extinction angle. Alpha is firing angle. Boleh nampak ke screen saya yang saya tulis ni?
Boleh tak?
Nampak, Doktor.
Okay, so firing angle dengan extinction angle. So what is meant by the conduction angle? Apa maksud conduction? Operasikan, operating, ataupun berfungsi. When is the condition it functions? Mana? It functions from alpha to beta, right? So
Yes.
this is the angle meant by conduction angle. Conduction angle. From alpha to beta. Because before alpha, it's not conducting. And alpha starting, it will
Boleh, kita
conduct
buat
because
soalan.
current is flowing. And after the beta
Dia buat
current,
soalan
it
PE.
becomes 0, not conducting. So conduction angle basically is alpha to beta. In other words, the angle is beta minus alpha. The range from beta to alpha, alpha to beta. So take beta value minus alpha. So your job is to identify what is beta, because why? Alpha is given as 45, right? So what is this beta? Then the answer is there. How to find the beta value? Any idea? This is a half wave control RL. Let's go back to the slide. Half wave control RL, mana dia? Control RL. Ni dia. Kan? Ni waveform yang kita nak lukis tadi kan? Alpha, beta. So, alpha, beta. Gambar ni ada. Lukisan ni ada. Lepas tu, ingat lagi tak equation yang panjang-panjang tu kat mana? Ni dia. Tu atas. Can you see it? I out is represented by this long equation. Then it can be simplified until for alpha between, for the angle between alpha and beta. This is what meant by the conduction range, or the angle, conduction angle from alpha to beta. The current is depicted in this diagram from 0 to beta, I out. And this current can be expressed in terms of this equation. Okay, so as I said, test or final exam, the equation will normally be given. Your job is to identify the VM peak value, the Z, how to calculate the Z impedance, what is the theta, how to calculate, and how to calculate the time constant tau, alpha and beta, of course, in. Can you tell me alpha and beta in degree or radian?
You can choose.
Which unit?
Degree aja.
Degree. Apa? Tengok ni. Ni degree ke? Ni degree ke?
Radian.
Radian ya. Make sure your alpha and beta ada dah. Tak ada kan? Alpha value is in radian. Ingat tak? Apa equation untuk tau?
2 pi.
Tau apa? Tau? Tak tahu. What is the equation for tau? Mana tahu? Banyak sangat. Tak ingatlah, cari ya. Tau tu sama dengan L over kat mana tak jumpa. L over R. Lepas tu theta? Ni dia. Tau. Tau sama dengan L over R. Sama ya. Tahun 2 pun you dah belajar kan. Lepas tu apa lagi? Z mana Z? Z. Ni dia. Z sama dengan R squared plus omega L. Omega tu apa? 2 pi F. And theta sama dengan tangent inverse omega L over R. So L dalam unit Henry dan R dalam unit ohm. Yang the thing that you need to take note is radian. Make sure it is in radian. So your job here in this question, mana question dia? Dia suruh cari conduction angle kan? And then we know that conduction angle is beta minus alpha. Alpha dah tahu 45 degree. So our job is to find beta. But the question is how to find beta? Anyone can tell me? Can you see this slide? Slide number 19. Okay, take note on 19 and go back and see. Extinction, yeah, extinction. This is beta. Beta can be found using the long equation just now. If you are given this equation, this equation, then you can plug in beta inside the variable. Control variable beta. Beta happens at what time? Beta happens at when this I current become 0. So the whole thing become 0. Then can we find beta? Can or not? First of all, we need to find this, right?
Yes. Yes, sir.
Beta minus theta. Beta minus theta. Nope. What do we need to find? Because beta we need to find. Then what else that we can find here? This one. Sine theta. Sine theta, we need to know what is theta lah. Theta is how much? Theta equation is found using this equation. Can you tell me what is the theta value? Calculate now. Omega L is given 0.1 Henry and then R is 37.7. Can you find what is theta? Need to go back to the equation. Where is the equation? Here this is for R uncontrolled, right? Let's see the control. Yeah, this one. Yeah, this is the equation. There's a spelling mistake here. Angel means the something else. It's supposed to be conduction angle. Yeah. So it's represented by the italic Y, gamma. Gamma is beta minus alpha. So plug in this equation. You see that this equation is slightly different compared to the uncontrolled. This is a controlled one, so we need to use this equation. Okay, don't worry, it'll be given. The rest of the thing will be the same. Now, we need to find the beta. Now we have to know, we know the alpha. We need to find the theta first. Theta equals to tangent inverse omega L over R. What is the value you get?
45 ada.
45. Okay, you plug in everything, you get 45 degree or 45 radian. Degree. Now, it seems to be very complicated, right? The equation is very long. But when you plug in, alpha is berapa? Alpha is given 45 degree. Now, theta is 45. Alpha is 45. What happened? 45 minus 45, what do you get?
0.
0. Can you tell me what is sine 0?
0.
Sine 0 is 0. So the whole term become
0.
0. What is left? Only sine beta minus theta. Okay, so the long equation now become very short equation. Okay, now you need to find this. This equals to 0, and then we rearrange, take the sine inverse, you get the answer beta. Can you do it and tell me what is beta? This is page 29, yeah? Look at page 29. Refer note page 29 for I omega t equation. Okay, what is the value for beta?
GG mah. Apa gili? Tengok ni. Berhantu dah tempat tu. Ada orang mati, ada orang mati jatuh. Ambil gambar.
Anyone? Where is everybody? So quiet. Beta can found or not? Forty-five. Mana tak nampak. Aisha say 0.785. Apa tu?
No, no, that's the incorrect one.
Okay.
Sorry.
Sharifah, 45 tu apa? Tanya balik saya, ada soal, tanda soal tu. 45. Apa tu? 45 is alpha, right? So beta cannot be 45, impossible. So what is beta? Alpha is 45. Beta berapa? Can you see the diagram again? You see that alpha is 45 and then you go to pi, right? Pi berapa? Pi oh, mana pi dia? Pi kan? Sini 2 pi lah, salah ni. 2 pi lah, bukan. 2 pi is what? 360
360.
kan? Salah tempat ni. 2 pi equivalent to 360 degree plus 45. Tadi siapa punya soalan ni? Bukan gambar ni. 2 to 5 tu silap ya. 2 to 5 supposed to be tempat lain. salah. 360 plus, because this is one full cycle already, half wave, so 2 pi plus 45. Lepas tu kita nak tengok equation ni kan. Are you guys listening to me? Can you listen to me? Boleh dengar?
Boleh, Doktor.
So just now we said that the sine alpha minus theta, the whole term becomes 0. What happened? So I for beta equals to 0 becomes Vm over Z equivalent in the bracket sine beta minus theta. Right? The whole term becomes 0. So what is left here? So what happened to this Vm over Z? If we bring it to the right hand side, still becomes 0, betul tak? Because it's divided by 0. Everything, the whole thing becomes 0 because we need to find the extinction angle. Find extinction angle, you equate the whole equation equals to 0. So sine beta minus theta equals to 0 because this one eliminated. So my equation becomes so simple now. So sine apa yang bagi kosong? Sine, look at the waveform. Can you tell me where is the possible location for beta? Look at the diagram that you just plotted. Where is the location of beta? In between pi and 2 pi, betul tak? Beta is over here. Pi, 0, 2 pi. So how do we guess from here? Beta should be alpha already calculated just now. Beta minus 45. Alpha, no. The theta just now calculated is 45 degree. So you just play around with the equation. If sine 0, you get 0, right? Sine 0. Sine pi also you get 0. Sine 0, impossible. Sine 180. Sine 180 not yet reaching alpha, beta cannot. So sine 270 tak. Sine 2 pi. Okay, sine 2 pi equals to 0. So sine 2 pi is what? 360, right? So this thing, I'll have to equate the whole equation here equivalent to 360. So that I get sine 360, I get equals to 0. So 360 equals to beta minus 45. What is beta now? Berapa?
315.
Betul ke?
No.
405.
405.
Salah. Sekejap.
Apa tu?
Reverse back. Reverse. Kan 360 lah. 360 jauh sangat. Okay. Start balik. To make this, sebab dia dekat dengan ni kan. So sine 180 equals to berapa sine 180? Sine pi kan? Sine pi berapa?
0.
Kosong. Kan? So sine beta minus 45 sama dengan kosong. Okay, kita samakan yang ini. So beta akan dapat berapa?
Aku ayat lah.
2 to 5.
Okay. Tadi kalau ambil 360 kan, dia akan jadi kat sana. Kat luar. Okay. Tapi kita punya beta kat sini. Kat tengah-tengah pi dengan 2 pi. So if you take 360, you'll be out of the range. So make sure that you pick the right one. So I'm picking the 180, right? So I get 2 to 5. Betul lah, 2 to 5 is here. 360 is here and 180 is here. So it's in between 80 and 360 because we already draw and we identified the beta is in this place. So from the equation, you need to be intelligent enough to identify what is the value of beta. You need to play around with the sign value. If you pick the beta here, salah. If you pick the beta here, also salah. Because you have to know where is the location of beta. Because you get so many answers for 0, isn't it? Sign appears to be 0 at many, many points. So we have to take the correct points, which is at 2 to 5 here. Okay, so now to answer the question, beta is 2 to 5. What is question required? Conduction angle. So now we can answer the conduction angle. Again, what is conduction angle? Conduction angle is beta minus alpha. So put in beta minus alpha equals to 2 to 5 degree minus 45 degree. Answer is? How long is the current conducting?
180.
180. So if you look at the picture, the yellow line that I conteng tadi tu, okay, is starting from 45 to 2 to 5. So the range will be 180 degree. The duration for the conduction. So the current conducts from 45 to 2 to 5 degree for how long? For 180 degree, that long. Any question? Any problem? Okay, so don't be fooled or don't be scared by the long equation of I omega t, because eventually it becomes 0 if you calculate correctly the theta value. You see that this alpha minus 45, you get eliminated. If, unless it's not the 45, I cannot eliminate, then you have to, what do you have to do? You have to rewrite everything and then press your calculator, okay? Make sure you know how to press the calculator. There will be cases that you need to press the calculator for the long equation. This is long equation, right?
Yes.
Okay, next. Boleh calculate tak the average load voltage and current?
Match found.
Average voltage, what is the equation we should use for V out?
Death match. Warm up.
I also cannot remember. So if in the case we cannot remember, what do we do?
See the formula.
We can derive the equation. This is the V out, right? So V out is starting from band to band. V out is the average value of VDC or output power, output voltage. So it's 1 over 2 pi because it's halfway from when to when. Vm sine omega t dot d omega t. So what do I fill in? It's starting from alpha, ending at beta. So you guys please make sure you know how to solve this equation, because this is called the derivation. So continue. Vm, I can bring it out if you liked. It's a constant. So integration of sine, do I get? Integration of sine, I get negative cos, and then we can proceed. So Vm, you bring it out over 2 pi. Now, this one, I got starting from high level of beta to the low level of alpha. So it's negative cos beta. Oh, what's this like that? Beta minus, this is a negative, so it's a negative cos alpha. Can I simplify further?
Teka. Yang tak ni. Kau AFK eh? Apa? Oh, aku dah log out tadi. Aku log out dulu.
It becomes what? Negative become positive. That will be cos alpha minus cos beta. Do we know the values? Alpha is, beta is. Silence. So VM, what is VM given the question?
Dominating.
Supply with the voltage, right? Vs equals to 120 VRMS. Okay. So if RMS value is 120, what is the VM?
Kalau ghost, on tap tak? Ghost
120 times sert 2, right? Because VRMS equals to V peak over sert 2.
Oh, ni aku pakai wifi kau.
So VM equals to VRMS times sert 2 divided by 2 pi cos 45 minus cos 225. Try to press your calculator. Do you get it?
Hmm. 38.2.
Berapa?
38.2.
38.2. Apa unit dia?
Volt.
Volt. Okay. So sometimes you get confused here between the radian and degree. Then you just ask yourself, it is in degree. Why? Because my calculator in degree apa? Degree mode. If you are putting your calculator in radian mode, then you be careful here. You press the wrong thing. But when you are doing this, what is the alpha and beta? Should I put it in? This alpha and beta, it should be in degree or radian.
So,
Take note there. Everything in radian. We already said that just now. Radian, maybe. So alpha, if it is equals to 45 degree, how do I change it to radian? I take pi. I take pi. So 180 times pi. So what is the value for alpha? 45 changed to radian. So 45 by 180 times pi. So equals to 0.785 radian. Put the word RAD there, radian. So beta will be 3.7. Betul tak? 3.7 something. If this, what is beta? 225 degree.
Bang, apa dos? Bodoh
Kira,
tak
okay. Make sure that if this is in the equation of that one, the values has to be in radian. If you just want to calculate the cos alpha, cos beta like this, you can put it in degree or radian. Depends on your calculator mode. So this one is 38.2 volt, quite straightforward, but make sure you know how to derive this. If the question doesn't say that you need to derive, then you can use the equation directly, like if you remember. Okay? But if you are asked to derive the equation, You have to start from line 1, 2, 3, and 4. Okay, 1, 2, 3, 4. Line 1 to 4 must be there to get the full mark. Okay, calculate the load voltage. I got it. And what about the current? I need to calculate the current. Are you telling me that I need to calculate this? Wow, so complicated. Because that is the current, right? Correct. That is the current. Provided that the current is discontinuous. But then we can make things easier. Average current can be found using I out equals to this one integration of the long equation. That is complicated. We can do approximation. If it doesn't say anything or it says anything, then we need to find out what does it say. What does it say? What is condition to make it continuous? Where is the condition? Condition 1 and condition 2. Ada tak? Tak ingat. Kat mana? So many slides, cannot find. Anyone can tell me? I can use the equation I out equals to V out over R, provided. What is the condition 1? Condition 2? Yeah, continuous
Match found.
current. Okay. If it is not continuous current, then you have to apply the long equation, this one. Page 20 or 19. This equation, you have to apply the whole equation if it is discontinuous. And this is meant for discontinuous because you have beta. But this is a condition when we can use the very simple equation like this one. Where did I write? Here. Provided that it is continuous. What is the condition for continuous? Number 2 or number 1, I cannot remember. It says that omega L is much larger than R. So we can check in this equation whether the L given is big. Do you think the L is big given the L is 0.1 Henry? Is it big or small? 0.1 Henry is 100 millihenry, right? Okay, so this is considered as big, yeah, big. If it is small, then maybe you have 10 millihenry, 1 millihenry. Okay, but you can make your assumption, like assume that the L given is large enough. Okay, how do I know? I don't know. I just assume. Assume that the L is large enough to ensure, I put this sentence so that I'm safe. To ensure what? Continuous current.
I'm out of here.
Comma, then, comma, I out equals to V out over R. Finish. Just now I calculated V out, right? 38.2. So 38.2 volt divided by R berapa?
Reloading. Masuk bila kau Rena border.
Okay, finish. That's all.
Shadows traveling.
Any question? This one I do the simplification or approximation provided that the L is large, and in this case it is large. If given 0.001 or just 1 milli or 10 milli, they are small. So we cannot do this approximation. Okay. Unless the sentence says this one. Assume that the L is large enough to ensure continuous current. Then you can do this.
Reloading.
Okay, remember this one?
Hubung kat aku
Ada soalan?
Enemy spotted A.
Alamak.
Ada soalan? Ada tak?
Spike down
Masih dah
A.
sampai?
One enemy
No,
remaining. 30
Okay,
seconds
tak ada
left.
soalan. Bagus. Then your job is to do question number 1. Question number 3. That's
They
all.
revealed their
Because
weaknesses.
I have discussed question
Not
number 2.
smart.
So finish. There's only 3 questions, right? So please complete your exercise, yeah? Prepare for test 1 and 3. Finish everything so that you can compile and give it. Okay, thank you everyone. Ada soalan nak tanya?
this? Thank you.
Anyone would like to take the attendance?
Gotta go.
Ya, boleh datang.
Thank you, Doktor.
Reloading.
Bodoh aku keluar kelas bunga. Kat mana mas? Kau sedut lah gila.